Hi friends, in this video we solve a signal sum system related questions asked in TRB 2016. The first question is, does the transform of a signal x of n is equal to 7 into 1 by 3 power n u of n minus 6 into 1 by 2 power n u of n converges if and only if? They ask region of convergence of Z transform. So here you see x of n is 7 into 1 by 3 power n u of n. This is in AN formula, right? AN u of n format. AN u of n, the Z transform of AN u of n converges where mod Z is must be greater than mod A. So here what is A? 1 by 3. So this one will converge for mod Z is greater than mod 1 by 3. This implies 1 by 3 Z must be less than 1. As Z I bring this side. Similarly, 6 into 1 by 2 power n u of n converges. Here A is 6. So mod Z is must be greater than 1 by 2. This implies 1 by 2 Z is must be less than 1. So what is the answer? Mod 1 by 3 Z must be less than 1 and 1 by 2 Z must be less than 1. So option A is a correct answer. Second question. The impulse response of an initially relaxed system is e power minus 2t u of t. So h of t is given. H of t is impulse response. To produce a response means output. Y of t is equal to t into e power minus 2t u of t. What is the input? So they ask what is input. So when input output impulse response is given, the relation is y of t equal to x of t star h of t. Here what they have given? Y of t, t into e power minus 2t u of t. X of t they ask star, h of t they have given 2 of e power minus 2t u of t. So I have given shortcut to find the convolution between two signals. You see my video on that. We know e power minus at u of t star e power minus at u of t is equal to t into e power minus at u of t. By solving the convolution by using direct method will take minimum 10 to 15 minutes, but in exam we have only 30 to 40 seconds, so we have to use shortcut. So you see e power minus 2t, this is t into e power minus 2t. So e power minus at, t into e power minus at means this should be equal to e power minus at only. So it is e power minus 2t u of t, this format. So my input must be e power minus 2t into u of t. Within 10 seconds you can finish this problem. If you use direct mathematical method, it will take a minimum 5 to 10 minutes, right? So use this shortcut, right? If you want more shortcut, please refer my video on shortcut method for solving convolution integral, right? Next one, I think it is a L, it must be L. In the question maybe it is L. Laplace transform of f of t is equal to 2 into s plus 1 divided by s square plus 2s plus 5. Find the f of 0 plus f of infinity maybe. So they ask initial value. This is infinity means final value. So we have to use initial value and final value theorem of Laplace transform, right? So what is initial value theorem of Laplace transform? X of 0 gives this initial value. X of 0 is initial value. T tends s tends to infinity, s into x of s. So s tends to infinity, s into x of s. So this is L of f of t is nothing but f of s. Substitute that f of 0. I want f of 0. F of 0 means s into f of s. So you substitute that. So limit s tends to infinity, s into 2s plus 1 divided by s square plus 2s plus 5. So if you substitute infinity by infinity, it will be indeterminate. So you should not do that. Take s outside. So limit s tends to infinity. This two constant, take it up. It's outside. So s into s square 1 plus 1 by s. From denominator, take s square outside, s square. So 1 plus 2 by s plus 5 by s square. Now if you simplify, what will happen? You see s squared cancel. When you substitute s infinity, 1 by infinity 0, so 2 into 1, right? Here when you substitute s infinity, 2 by infinity 0, 5 by infinity 0, so it is 1. So option is 2. So f of 0, initial value is 2. What about final value theorem? Final value f of infinity is limit s tends to 0, s into f of s. So limit s tends to 0, yes, f of s is 2 into s plus 1 divided by s square plus 2s plus 5. When you substitute s is 0, surely it will become 0. So final value is f infinity is 0. So initial value 2, final value is 0. So option B is a correct answer. Next problem. Okay. Double integration of unit step function would lead to. So we must know that what do you call double integration of unit step function. So when you integrate unit step, what do you get is, sorry, this unit impulse. When you integrate unit impulse, you get unit step. When you integrate unit step, what do you get is unit ramp. When you integrate unit ramp, what do you get is unit parabola. So double integration of unit step. One integration of unit step will give ramp. Two integration will lead to parabola. So the option B is a correct answer. Similarly, we must also remember differentiation of parabola will give ramp. Differentiation of a ramp will give unit step. Differentiation of unit step will give unit impulse. Please remember. Okay. Next one, the ROC of Z transform sequence 5 by 6 power n u of n minus 6 by 5 u of minus n minus 1. So just now only we have seen this is in a n u n formula. So 5 by 6 power n u of n, right? So this is in the format of a power n u of n. This will converge only mod z is greater than a. I have told in the first format itself. So a is 5 by 6. So mod z be greater than 5 by 6. Right? This is 6 by 5 minus. So minus 6 by 5 power n. It must be u of minus n minus 1. Then only answer will be correct. So this is in the format of minus a power n u of minus n minus 1. This will converge only mod z is less than a. So what is a here? 6 by 5. So mod z must be less than 6 by 5. So one sequence converge for mod z is greater than 5 by 6. I can write mod z is greater than 5 by 6 like this also. And another sequence converge mod z is less than 6 by 5. Mod z must be less than 6 by 5. So total sequence will converge when z varies from 5 by 6 to 6 by 5. So the option is 5 by 6 to 6 by 5. Next problem, consider a discrete time system with input x of n, output y of n, related by y of n is equal to 10 log of x of n divided by 10, sorry, base 10. Whether the system is causal or stable or not, we have to find. For a non-causal system, we know the system is non-causal, present output depends upon future. Otherwise, the system is causal. Here you see this is present output, this is present input only. So the present output doesn't depend on future input. So surely the system is causal. For stability, we have to see bounded input must produce bounded output. BI is bounded input. Bounded input must produce bounded output. Bounded input means finite input. If I apply finite input for x, surely y will be finite because log of finite value is finite only. So bounded input produce bounded output. Surely it is a stable system. So answer is option B. Next. Okay. This question is a very good question. Right, let us see. The range of values of A and B for which LTI system with impulse response will be stable. So they have given impulse response h of n. So h of n is a n when greater than or equal to 0, b n when n is 0. Right, it is LTI system with impulse response. LTE system with the impulse response is stable when impulse response is absolutely integral, summable. Absolutely summable means you must be able to sum the impulse response. This is the condition for LTI system with impulse response must be stable, right? So here they have given for case 1, n varies from 0 to infinity. So I change from 0 to infinity. H of n is a power n. That must be less than, if this is the case, what should be the value of a we have to find. This implies a must be less than 1 only. Why a must be less than 1? Because if you substitute a is equal to 2, what will happen? It will become 2 power n. When n is 0, it will become 2. When n is equal to 1, it will become, sorry, n0, it is 2 power 0, 1. When n is equal to 1, 2 power 2, 2 power 1. When n is equal to 2, 2 power 2, 4. Up to infinity, if you add, the summation will become infinity. It is not absolutely summable. So a must be less than 1. Clear or not? So if a is less than 1, why it will not become infinity? You see that if a is less than 1, what is the condition? When n goes to 0 to infinity, an will be 1 by 1 minus a, for a is less than 1. So we can sum it up, right? When a is greater than 1, we cannot sum. So it will sum become infinity. So for case 1, a must be less than 1. Second, you see n is less than 0, right? So n is less than 0 means in this formula, n varies from minus infinity to minus 1, bn. This must be less than infinity. So for negative, this b must be greater than 1. Why? If b is less than 1, what will happen? Suppose if b is, let us assume 2, sorry, less than 1 means 0.5 or 1 by 2, it will become 1 by 2 power n, right? So when n is equal to 1, it will become 1 by 1 by 2, 2. When n is equal to 2, it will become 1 by 1 by 2 power 2, 4. So it will go up to infinity. So the function will become infinity. It is not absolutely summable. So for this equation, the system will be stable when a is less than 1 and b must be greater than 1. Right? Next one, the z transform of 1 by n factorial is, surely it is a direct question, simple question, e power 1 by z, right? So this you must know. Next one, the analog signal given below is sampled by samples of 600 samples per second. Fs equal to 600 samples per second. What is the folding frequency of the signal? Folding frequency ff is given by fs by 2. So that means 300 samples per second or 300 hertz. So direct question, option C is the right answer. Next. Okay. The impulse response of DT LTA system is given by, impulse response I consider as h of n, right? They have given x of n, but we write h of n general format, n into 1 by 2 power n u of n. Whether the system is stable, causal or dynamic. So whenever they give, we can solve this problem in two methods. Here I take the transform of this one, right? So if I take the transform, what is the answer I get is 1 by 2 z inverse divided by 1 minus 1 by 2 z inverse whole square, because n into a n u of n as a z transform of a z inverse divided by 1 minus a z inverse whole square, right? So when I know, this is the transfer function. When I know transfer function, how the system var mod z is greater than 1 by 2 ROC. Right? When I have a transfer function, the system is stable if all poles are lying inside the unit circle. What is the pole here? Where we have two poles, P1 and P2 with value 1 by 2. 1 by 2 is less than 1. So poles are inside unit circle. So it is a stable system. Right? So for causal system, what is the condition? ROC must be outside the outermost pole. What is the outermost pole? 1 by 2. Because we have only two poles. One pole is at 1 by 2, another pole is at 1 by 2. So outermost pole is 1 by 2. For causal system, ROC must be outside outermost pole. If I know transfer function. So outermost pole is 1 by 2, ROC is greater than 1 by 2 only. So ROC is outside the outermost pole. So system is causal also, right? But we cannot say whether it is dynamic or not, because for that we need input-output relationship. So the system is dynamic if present output depends on past input, past output. But we don't have any input-output relation. We have only impulse response. So option, it is a causal and stable system only. So option A is a right answer. Next. The Fourier series expansion of an even function contains the direct question. Even means cos, odd means sine only, but cos and constant, that is very important. Odd function means it is even periodic, odd means only sine. Okay. Principle of superposition is applicable only for linear system, direct question. Next. Find the Laplace transform of u of minus 2t minus 1. This is one beautiful problem. Here you see, first let me start with u of t. Laplace transform of u of t is 1 by s. Next I apply shifting property of Laplace transform. L of u of t minus 1 as a t plus 1 I find that is given by 1 by s e power s. Shifting property. What is shifting property of Laplace transform? U of t minus t has a Laplace transform of 1 by s e power minus st. Instead of t, here we have minus 1, so e power 1 by s e power s. Next, what I do, I apply scaling property. L of u 2t plus 1. Right? Scaling property means what will happen? It will become 1 by 2, 1 by s by 2 e power s by 2. Scaling property of Laplace transform. What is saying? L of x of at is 1 by a. Here a is 2, so it is 1 by a. X of s by a. S must be replaced by s by a. Here wherever s is there, that must be replaced by s by a. A is 2, so 1 by s plus 2 e power s by 2. So this is what scaling property. So this 2 will be cancelled. Next, I apply time reversal. I apply minus. So minus 2t minus 1. That will be having minus 1 e power minus s by 2. Time reversal property of Laplace transform. L of x of t is given by minus t. So this is x of t means this is x of minus t. X of minus t means s must be replaced by minus s. So it is 1 by minus s minus 1 by s e power minus s by 2. So option D is a correct answer. Right? So simple problem, but you must be very careful, right? Next problem is what they have given. Okay. Fine. Here they have given x of a. The Fourier transform of x of n is given by x of k. X of k is given by 4 comma 1 plus 2j comma j 1 minus 3j. So it is x of k0, k1, k2, k3. What they ask is Fourier transform of x star of n. Fourier transform of x star of n is given by x star of n as a Fourier transform dft of x star of n minus k. So what I need to do, here n is equal to 4 because it is a 4 point. 1, 2, 3, 4. So n is equal to 4. So first I need x star of 0. X star of 0, that means x star of n minus k. So n is 4, right? K is 4. Then only I will get x. Right? Sorry, x star of 0. X star of 0, n minus, x star of n minus k. N is 4, k is 4, then only I can get, right? We know that it's a 4-point DFT. 4-point DFT means it will vary from 0, 1, 2, 3. 4 is same as 0 because DFT is a periodic. So x star of 0 is equal to x star of 4, right? So x star of 0 is, what is the property? X star of 0 is equal to x star of 4. Both are same only. So this is possible. So I want k0. K0 means I substitute x star of n minus k, that is x star of n is 4, k0, x star of 4. X star of 4 is nothing but x star of 0. So what is x of 0 from the problem? X of 0 is 4 means x star of 0 is also 4. Clear? Next. This is k0. Next I want to find k is equal to 1. So that is x star of n4 k1. So that is x star of 3. X of 3 is 1 minus 3j. X star of 3 is 1 plus 3j. So first this is k0, k1. Similarly k2 means it is 4 minus 2. That is x star of 2. X of 2 is j. X star of 2 minus j. Next k3. Because 4-point DFT means k varies from 0, 1, 2, 3. K3 means if we substitute n4 k3, x star of 3. X star of 3, x of 3 is 1 minus 3j, x star of 3 is 1 plus 3j. So when k0, 4. When k1, 1 plus 3j. When k2, minus j. When k3, 1 minus 2j. So option A is the right answer. Fine? Okay. And the last problem is, what is the final value of x of z? So they talk about z final value theorem of z transform. So that is telling it is final value, so x of infinity. So final value theorem states that z tends to 1, z minus 1, z into x of z. This is what final value theorem. So limit z tends to 1, z minus 1, z into z minus 2 divided by x of z is given here. Z minus 1, z minus 0.5. This will be cancelled. Substitute z is equal to 1. So 1 into minus 1 divided by 0.5. This minus 2. So the answer is minus 2. Right? So that's all about this session. I hope you understand the problem. If you have any doubt, please ask me in comment section. I will clarify. Thank you.